In this video, we discuss about one of the important concepts of functions in C language, that is recursion. Coming to the definition, recursion, it is the process of a function calling itself is called as recursion, or the mechanism of a function calling itself is called as a recursion. Recursion is also called as circular definition, and the function which calls itself is called as a recursive function. A function which is calling itself is called as a recursive function. Now see this example. Here there is a factorial function which finds factorial of a given number. Now the name of the function is factorial, and in the factorial function at one point of time it is calling the same function, that means it is calling itself. So now this factorial function is called as a recursive function, and this entire process is called as a recursion. Now we see types of recursion. There are two different types of recursions: direct recursion, indirect recursion. What is direct recursion? Now see here, there is a function A, and in this process there is a function A, and in the A function code at one point of time it is calling itself. That means A is a function, while it is executing it is calling itself. This type of recursion is called as direct recursion. A function calling itself is called as a direct recursion. But now observe here in the second case, indirect recursion. In this there are two functions, A function and B function. At one point of time A function is calling B function, and while B function is executing, at one point of time it is calling A function. That means control is transferred from A function to B function. Again the control is coming to A function, and this process is repeated. That means A function is calling B function, and after some time B function is calling A function, and this process is repeating. This type of recursion is called as indirect recursion. That means A function is indirectly calling itself. In the first case, A function is directly calling itself. That's why it is called as direct recursion. In the second case, A function is indirectly calling itself via B function. That's why it is called as indirect recursion. Now we see another important concept in recursion, that is how to exit from recursion. Then we may get a question, why we need to exit from recursion? What is the need of exiting from recursion? Now observe here, this is the recursion concept. A is the function. At one point of time it is calling itself. Now what happens here? Now program control comes to execute the statements in this order, and whenever program control gets A function call, it again calls A function, and again the code continues to execute A function, and again it calls A function. That means this process is repeated. Then that means if we do not stop recursion, then the program enters into infinite loop. That means it will call A function number of times. How many number of times? It will call infinite number of times. Then there must be one point of time we need to exit from the recursion. Then in order to exit from recursion, then we need to use one base condition. Then we need to specify a base condition in order to exit from the recursion, or in order to stop the recursive function calls. So we need to write a base condition, and the purpose of base condition is once that particular condition is satisfied, then we will exit from the recursion. recursion. Otherwise, the program continuously executes, the program continuously calls the same function, and this execution goes for infinite number of times. And the purpose of base condition is to exit from the recursion at a particular point of time. Now observe here, this is the factorial function, and this factorial function finds factorial of a given number, and in order to avoid the execution of infinite number of times, and in order to avoid in order to avoid to enter into infinite loop, here we are using one base condition. What is the base condition here? If n value becomes 1, then we are executing statement return 1. This is the base condition, and return 1 is the statement related to the base condition. Now this entire part will come under the base condition and its related code. Whenever this particular base condition is executed, then automatically recursion will be stopped, and then there will be no more function calls. This is how we exit from the recursion. If we do not specify base condition, what is the problem here? If we do not specify base condition, then the recursion process will enter into infinite loop. In order to avoid that particular case, we need to specify base condition, and the purpose of base condition is to stop the recursion and to exit from the recursion. This is about details about recursion. In this video, we have seen about definition of recursion and another name for recursion, and also what is a recursive function, and also we have discussed about types of recursions, direct recursion, indirect recursion, and last one we have discussed about how to exit from the recursion.